Hi everyone, I'm Hendra. Today we will discuss about factors, the introduction to factors. The aim for this lesson are, as you can see here, the first one is for you to understand the basic properties of factors, both in 3D and 2D. The second one is the component factor, to understand the component of factors. And then the third one, addition and subtraction of factors. And then how to calculate the magnitude of factors, and the last one will be the unit factors. Right, let's jump in. What is a factor actually? Well, suppose you are going from your house to your school. Let's say that the distance, let me draw it in this diagram. Let's say here is where your house is, and let's say here is where the school, and the distance of these two places is 10 kilometers, and of course the direction is you are going from house to school. Let's say you are going to northeast. So if you connect these 2 points, you will get the line which the displacement is 10 kilometer and the direction is toward northeast, and this thing is called vector, right? In other way that we can say that the vector is a movement through a certain distance and in a given direction. So you know the distance and you know the direction. Another example, let's say if you are going back home from school to your house, you're going back, and of course the distance will be the same, 10 kilometers, but now the direction will be in the opposite when you're going back to your house. So that's also a vector, but with different direction, with the same distance. Why the concept of vector is important? Let's say one day you choose to be an army, or even a video game creator. In an army situation, you need to deal with the flying planes, or if you are familiar with the radar, or if you're a submarine, etc. Those are one of many applications that you can use vector for. And of course there are many other examples that you can find in the real life, the application of vectors. In general form, let's use the Cartesian diagram here. If I say this is the y-axis and this is the x-axis, and let's say the coordinate of the school at the point, let's say A is the school at the point 6, 8, and of course this is the origin, which is 0, 0. In this case, let me clean this, let me redraw the diagram. In this case, when you have a certain point A, you can always make a line from the origin to that point with a certain direction, which is in this case is, let's say, 10 kilometer. The drawing scale might not be accurate, but the idea is when you have a point you can always make a vector from the origin. In this case, when you have the point A68, that means you need to move 6 right, 6 units to the right, and 8 units up. Let's represent a vector. We can say the vector OA is 6, 8. That means 6 units to the right and 8 units up. And anyway, this is called column vector. And this is one of the way to represent vector. Other way to represent vector is using a lowercase. Let's say this is the vector A, which is we use lowercase with a straight line underneath, or lowercase with a wavy line underneath. Or in certain book you will see a lowercase with bold. But in any exam or any writing that you can use, this is the most common one. Either you are using the lowercase with a straight line or a wavy line, or stating the initial point and the end point of a vector. Speaking of which, the origin is called the initial point, and the A here is called the terminal point. In this case, this vector represents from the point O to point A. So that's why we state OA with the line on the top of that, from O to A. Right? Okay, now let me make another one of the diagram. Let's use a proper one now. So let's say if I have the Cartesian diagram here, this is the x-axis, y-axis. So previously this is the origin, and we have a point here where your school is, O is where your house is, and we can make a line which we call as a vector with direction from O to A. Now what if I have another point on 2, 0, which is here? Let's call this point B. This A is 6A and B is 2, 0. And another point on the here. Let's say that's point C. So here is point C where A. If I make another line here with the same direction, then I have two vectors. This is called vector OA, and this is called vector BC. Let's call them that. Now, if I ask you a question, what does actually the vector BC represent? If it's if you look at the diagram, you can see the column vector of vector BC is 6, 8 also. So 6 to the right and 8 up. So does it mean the vector OA and BC are the same? Well, technically it is, but it's no. It's called, so OA, let me write it here. OA and BC are parallel. So vector OA and vector BC are parallel. What is a parallel vector? A parallel vector is vector which has same direction regardless the initial point and the length of the vector itself. So as long as it has the same direction, then you can say it's parallel vector. So in general, I can say, let's say vector OA is equal to some multiple of vector BC. This symbol here is called lambda. It represents how many longer or shorter. How many longer or shorter the vector is.